Triton, Neptune's largest moon, is one of the most extraordinary and mysterious objects in our solar system. With a diameter of nearly 2,700 kilometers, it is larger than Pluto and almost as large as our own moon. But despite its size, Triton has only ever been visited once by a spacecraft, when Voyager 2 flew past Neptune in 1989. That brief encounter revealed a world unlike any other, and it left scientists with more questions than answers. To this day, Triton remains one of the most enigmatic places in the outer solar system, a captured world whose origin, evolution, and present state defy the patterns we see elsewhere. Before we dive into the strange and hostile world of Triton, Neptune's largest moon, make sure to hit that subscribe button and turn on notifications so you never miss our deep dives into the most fascinating corners of the universe. Welcome back to Beyond the Stars. Your journey through space starts now. Unlike most moons, which orbit in the same direction as their planet's rotation, Triton travels in the opposite direction. This retrograde orbit is extremely rare and strongly indicates that Triton did not form alongside Neptune. Instead, scientists believe Triton was once an independent world in the Kuiper Belt, similar to Pluto, before being pulled into Neptune's gravitational grasp billions of years ago. That capture event would have been catastrophic. The sudden arrival of such a large object could have disrupted Neptune's original moon system, ejecting some moons into space and shattering others in violent collisions. Scars of this ancient upheaval may still linger in Neptune's strange ring system and the orbits of its smaller moons. Triton's orbit is also tilted at an extreme angle, 157 degrees relative to Neptune's equator. Combined with its retrograde motion, this makes Triton unique among all the large moons of the solar system. Its captured origin also hints at its composition. Like Pluto, Triton is thought to be a mixture of rock and ice, with a significant fraction of volatile materials such as nitrogen and methane. These ices dominate its surface, which Voyager 2 revealed to be strikingly bright and reflective. Temperatures on Triton are among the coldest known anywhere. The average surface temperature is -235 degrees Celsius, just 38 degrees above absolute zero. In this deep freeze, nitrogen exists as solid ice, and methane lies frozen on the ground. Yet despite the extreme cold, Triton is not a dead world. Voyager 2's images revealed a surface that looked young, dynamic, and surprisingly active. Instead of being covered in ancient impact craters like most moons, Triton's terrain was fresh and constantly renewed. There were vast plains of frozen nitrogen, ridge terrains shaped by internal stresses, and, most unexpectedly, geysers erupting into space. These geysers were not eruptions of molten lava like those on Earth. Instead, they were cryovolcanoes, volcanoes that spew icy materials rather than rock. Voyager captured plumes of nitrogen gas and dust, reaching as high as 8 kilometers into the thin atmosphere. The existence of such eruptions proved that Triton is geologically alive, driven by internal heat, despite its great distance from the Sun. Scientists believe the heat comes from the slow decay of radioactive elements in Triton's rocky core, combined with the tidal flexing caused by Neptune's immense gravity. Beneath Triton's frozen crust, there may be a subsurface ocean of liquid water, perhaps kept warm by salts and ammonia that lower its freezing point. The possibility of a hidden ocean makes Triton one of the most intriguing worlds for astrobiology. Everywhere we have found liquid water in the solar system, we consider the potential for life. On Earth, life thrives in deep oceans, near hydrothermal vents, in complete darkness, and at high pressures. If Triton's ocean exists, it may harbor the right chemical ingredients to support microbial life. This prospect alone makes Triton a prime candidate for future exploration, despite the challenges of its distance and harsh environment. But let's step away from theory for a moment. Imagine what it would actually be like to stand on Triton, even briefly. What would 5 seconds on this alien moon mean for a human being? The answer is both terrifying and illuminating. The most immediate threat would come from Triton's atmosphere, or more accurately, the near absence of it. Triton's atmosphere is 70,000 times thinner than Earth's, composed mostly of nitrogen with trace amounts of methane and carbon monoxide. In such low pressure, human lungs could not function. Exposed to this vacuum, the air in a person's lungs would expand violently, causing severe internal damage. Moisture on the skin, in the eyes, and in the mouth would begin to boil away in a process called ebullition. Consciousness would fade in less than 10 seconds, and survival beyond that would be impossible without protection. At the same time, the extreme cold would inflict devastating effects. At -235 degrees Celsius, skin and tissue would freeze almost instantly. Materials that are flexible on Earth, like rubber or plastic, would become brittle and shatter. Any exposed electronics would cease to function. The environment is not just cold, it is profoundly hostile to life as we know it. Gravity on Triton provides a strange contrast to these lethal conditions. At only 8% of Earth's gravity, a human would weigh almost nothing. A person who weighs 70 kilograms on Earth would weigh barely 6 kilograms here. Walking would feel effortless, and a simple hop could send someone soaring several meters into the air. Yet this low gravity also makes movement unpredictable. A misstep could send someone drifting uncontrollably, unable to regain footing, in a world covered with jagged ice ridges and hidden fractures. The landscape itself would be both breathtaking and alien. Lanes of frozen nitrogen stretch for hundreds of kilometers, broken by ridges, valleys, and pits shaped by geological forces unlike any on Earth. In the distance, one might see the towering plumes of cryovolcanoes, shooting geysers of nitrogen and dust high into the sky. Voyager 2's images showed dark streaks trailing across Triton's bright surface, created by geyser plumes, blown sideways by gentle winds in the thin atmosphere. To witness one of these eruptions up close would be awe-inspiring. A silent explosion of icy material reaching kilometers above the ground, resettling as a fine frost that constantly renews the surface. Yet to a human standing there, even in a protective suit, these eruptions could pose serious dangers. A geyser could blast a person with freezing particles moving at high speeds. The shifting surface might crack or collapse underfoot. Triton is alive, but in a way that resists human presence. If we imagine not just standing on Triton, but attempting to explore it, the challenges multiply. Any spacecraft landing here would need advanced thermal systems to withstand the cold. Life support equipment would need to function in near vacuum. Communication with Earth would take more than 4 hours for a round trip, making real-time control impossible. Autonomous systems and artificial intelligence would be essential for survival. And yet, despite all these hazards, the allure of Triton is undeniable. It is a captured world, a reminder of the violent processes that shaped the outer solar system, and perhaps even the emergence of life beyond Earth. Until then, Triton remains distant and mysterious, orbiting Neptune in silence, a world of ice, fire, and possibility. It is a reminder that the most extraordinary places are often the hardest to reach, and that sometimes, just imagining what 5 seconds on such a world would be like can change the way we see our place in the cosmos. Triton challenges everything we thought we knew about moons, from its backward orbit to its icy volcanoes and the possibility of a hidden ocean. It's a reminder that the solar system still holds secrets waiting to be uncovered. If you enjoyed this exploration, make sure to like the video, subscribe, and join us next time as we uncover more mysteries of the universe.